All right, today we're doing something really cool. We're going to go from this, a pile of parts, to this, a fully working FM transmitter. And look, this isn't just some weekend hobby kit. Nope, this is a professional challenge designed to build some serious, real-world skills. You want to see how it's done? Let's get into it.
So, let me ask you something. How do you really learn a practical skill? I mean, really get it down. You could read a book, you can watch a video, but is that enough to actually do it? I think we all know the answer to that, right?
Yeah, exactly. The real learning, especially with tech stuff, happens when you actually get your hands dirty. You know? A textbook might tell you what a circuit is supposed to do, but a challenge makes you figure out why it's working, or more often than not, why it's not working. And that right there, that's the whole idea behind challenge-based learning. It's all about learning by solving actual, tangible problems.
Okay, so what is this challenge? Let's take a look at the blueprint, the mission brief for these students. And I'll tell you right now, it's way more than just snapping some parts together. The mission, should you choose to accept it, is pretty straightforward on the surface. You take this RFO2FM kit, just a bag of resistors, capacitors, all that good stuff, and you have to turn it into a device that can be configured and tested like a pro would. So you've got 3 big steps: build it, tune it, and then prove it.
Now this is what I find fascinating. Take a look at how this whole thing is graded. The actual assembly, that's only 10%. Safety, another 10%. I mean, that's just the price of admission. The real meat of the challenge, a whopping 80% of the score, comes from the configuration and the professional level testing. See? This isn't a soldering class. This is an engineering challenge.
All right, first things first, let's get building. Phase 1 is all about taking those loose parts and bringing this circuit to life on the PCB.
And there's a real method to the madness here. You build it from the smallest components to the tallest. So you start by laying down the foundation, all those little resistors. Then you've got to be super careful with polarity for things like the capacitors and the LED. Get that wrong and poof. After that, you install the brains of the operation, the transistors. Then the tuning coils, and finally all the interface stuff, like the mic and antenna jack. It's all about order and precision.
And this right here, this is what separates the pros from the amateurs. These aren't just suggestions, they're the golden rules. You verify every single component before you solder. You double and triple check the polarity on that LED and capacitor because, yeah, you don't want to see that magic smoke. It's about having a clean workspace, managing your waste. It's all about discipline. That's the key.
Okay, so the board is built, it looks pretty good, but the big question remains, does it actually work? This next part is the moment of truth. Time to power it on for the very first time, the awakening.
So, you give it its first little bit of juice, just 3 to 6 volts, nothing crazy. You have to be careful to limit the current too, just 15 to 20 milliamps. And if you've done everything right, you get the first sign of life. That little red LED just glows. And it's a beautiful thing. It means power is flowing, we're in business.
And I absolutely love this quote from the actual guide. A little bit trial and error on this. It's just so real, right? It reminds you that even for professionals, it's not always a perfect science on the first try. Tuning this thing isn't just flipping a switch. It takes a bit of feel, a bit of patience, a delicate touch.
And here's how that trial and error plays out. The student is carefully adjusting this one little component, the variable inductor. And at the same time, they're listening on a plain old FM radio. So you give it a tiny little twist, nothing but static. Another nudge, more static. You're thinking, did I mess this up? And then, all of a sudden, bam! The audio you're piping in just comes blasting through the radio, crystal clear. That is the magic moment, right there. That's when your silent little circuit finally finds its voice.
But hey, just making it work isn't enough. Not for this challenge. Now comes the real mastery. Now you have to prove that it works perfectly. And to do that, you need some serious tools. Tools that literally let you see the invisible.
First up is something called the standing wave ratio, or SWR for short. Sounds kind of technical, I know, but the garden hose analogy is absolutely perfect. Imagine you have a kink in your hose. The water can't get out, right? It just backs up. A high SWR is exactly like that, but for radio waves. The signal gets reflected back instead of going out the antenna. So your job is to get that number as low as you possibly can to make sure all your power is actually being broadcast. Okay, now this is where it gets really cool. The spectrum analyzer. This piece of gear is a total game changer. It literally takes that invisible radio signal and draws you a picture of it on a screen. So now you can see exactly what frequency you're on. You can see how wide your signal is, and most importantly, you can see if it's clean or if you're accidentally broadcasting a bunch of junk on other frequencies. And this is how they prove they've mastered it. They don't just say, it's good. They log the data. This is basically their test sheet. They're writing down the SWR before they made adjustments and then the SWR after. They're looking at that spectrum analysis and certifying that the signal is pure, that there are no weird, spurious emissions. It's all about the data. Because, hey, the numbers don't lie.
So, let's recap. The transmitter works, the signal is clean, the data is all logged. We must be done, right? Nope, not even close. There's one last step, and this is the one that really locks this in as a professional job.
Because as any pro will tell you, the job ain't done till the paperwork is done. The final thing they have to turn in is a full-blown technical report. And I mean everything's in there. Photos of their soldering work, the final voltage and frequency settings, all that SWR and spectrum analyzer data. Even a summary of the safety rules they followed. It's the complete story of the device, from start to finish. So that brings us to the big final question, doesn't it? When you look at this entire journey, from a box of parts to a fully documented, tested device, what's the real difference here? What separates a fun little weekend project from a truly professional piece of work?
It all comes down to one simple word: proof. That's it. It's the documented, repeatable, data-backed evidence. The proof that you didn't just build a thing, but you understand how it works, you configured it the right way, and you can prove with hard numbers that it meets professional standards. And that's the real takeaway. Thanks for watching.